Welcome to Math 1314, Section 5.1. This is all about systems of linear equations. Linear meaning that we're talking about lines. And in this case, the question is, do two lines intersect in a common point or not? So in this first picture here, I've got one line in blue, one line in red. They do intersect in a common point, and we're calling that point x1, y1. It could be that my two lines are parallel. They have the same slope and they would never cross, so there would be no intersections. And as silly as it seems, it is possible that I could have exactly the same line, which means that if they're the same line, they're on top of each other and they're actually intersecting at every point. Therefore, there would be an infinite number of solutions. Now you might say, how is it possible you had the same line and didn't know it? Well, for example, here's one line, x minus y is 5. If I simply multiply each term by 3, I get something that looks different. And at first glance, you would think that these are two different lines, when in reality they are the same line. Alright, so let's take a look here at some problems. Here we have our system of equations. And what they're simply asking us is several points, 1, 2, and 6, 3/4, are they solutions to the system of equations or not? Well, let's see. 1, 2, x is 1, y is 2. Plug it in. 5 plus 12 is 17. Yeah, 17 is equal to 17. What about the other one? Minus 6 times 1 plus 4 times 2. Well, that would be minus 6 plus 8, and is that 2? Yes. So, the first ordered pair is. What about the second? X is 6, y is 3/4. Well, let's see, that would be 5 times 6 is 30, plus 6 times 3/4, that's 18/4. And the question is that 17? Well, I don't have to actually make the calculation because this is 30 plus something. Well, there's no way 30 plus something is going to be back down to 17. So that particular point would not solve the system. All right, in question 2, they are giving us two lines, and they're wanting us to figure out, do they intersect in one point? Are they parallel? Or are they the same line? So looking at it, I'm noticing the slope of the first is 3/4. The slope of the second is 1/9. Well, they're not the same slope, so they're not the same line. Therefore, they will intersect in one point, giving the system has one solution. Now, in terms of the other particular problem, we have, if it had no solution, that would be parallel lines, and infinitely many solutions would be the same line. All right, what about question 3 here? Let's see. Slope is 8. Oh, this one has a slope of 8 as well. So these do have the same slope, but I'm looking at the end here, the b, and they do have different y-intercepts. Therefore, they are parallel lines, and since they are parallel lines, they will never intersect. Right, here's the first one crossing at 1/2. Here's the second one crossing at -5. So the system has no solution, and we say that the system is incomplete. inconsistent. Question 4. Question 4, I've got 9x plus a third. And the second one is 9x plus a third. Oh, that's interesting. Same slope, same exact y-intercept. Therefore, these are the same line. If they're the same line, they are intersecting at every point. So the system has infinitely many solutions, and we say the equations are dependent. So whenever it has infinitely many, it's dependent. If it has no solution, it is inconsistent. All right, in question 5 here, we're actually going to solve this system of equations. And we're solving it by the substitution method. What does that mean? Well, I look at my two equations and I pick one of them and I solve for a variable that's easiest to isolate. Doesn't matter if you isolate the x or the y, just pick something easy. This one has a 2 in front of it, this one has a 5, this one has a 4. Oh, there's an x all by itself. So I'm going to use that one. So I move the 4y to the right hand side and I get x is minus 4y plus 27. So I take that and I substitute it into the other equation. Well, here's the other equation, and I simply substitute in now what I know about x. 2 times minus 4 is minus 8. 2 times 27 is 54. And so I get minus 3y from the minus 8 and the 5. 33 minus 54 is a minus 21. And we get y is 7. So yes, we found y, but we're not done because we need both an x and a y. So I take that y and I plug it back into what I knew about x. And so minus 4 times 7 is a minus 28 plus 27. And I get minus 1. All right. In question 6, we're trying to solve this system by a technique called addition or elimination. My hope is that I can add these two together and get an x or y to cancel. And you can multiply one equation or both equations by something so that it would make them cancel. So what if I wanted the x to cancel? Well, I'm going to multiply the top one here by negative 1 all the way across. So minus 7 plus 2 minus 16. You add them up, I get 16y is 96. And dividing both sides by 16, I get that y is 6. Now at that point, you don't have to eliminate anymore. You could simply take the 6, plug it back in for one of these y's and solve for x. In this case, I just wanted to show you what you would do to make the y cancel. How would you make the y cancel? Well, let's see. I've got a minus 2 and a 14. If I simply multiplied this by a 7, I'd have a minus 14 add 14, which would be 0. So that's what I did. I multiplied it by 7. Add them up now. The y's do cancel. I get 56x is 224. Dividing both sides by 56, and you get x is 4. So the point of intersection then is going to be at 4, 6.